Now let's look at the absolute value. Maybe it's been a while since you've used this, so we're going to do a quick review. So first let's think about the number line here, where you got negative numbers over here and positive numbers on the right side. And you can think about numbers as a direction. So like negative numbers indicate going to the left. So if you do 0 plus negative 6, it means go that way. And if you do 0 plus positive 6, you go to the right. But you can also just think of numbers as a distance. So the distance of negative 6 from 0 is still 6 units, just like the distance of positive 6 from 0. So that's one way of defining absolute value, is that the absolute value of x is the distance from 0 to x on a number line. So that means the absolute value of negative 6, the distance is the distance from negative 6 to 0 on a number line is still 6 units. And the absolute value of positive 6 is also 6 units. So that's an example of that. Now here's this alternate definition, which actually does the same thing that I want to look at right here. So this is some weird notation you might not be used to, and I want to go over what this means. This is a formula that defines this absolute value function, like what is the output going to be? It's going to be one of two things. So the input here is x, and the output is the stuff over here. The formula for this function is either the absolute value of x is just equal to x if x is greater than or equal to 0, or if x is less than or equal to 0, you use this other formula. So this is an example of a piecewise definition of a function because it's made out of two pieces, this piece and then this piece. So let's just do a quick example of how you can read this. Let's say you're taking the absolute value of, I don't know, x equals negative 5. Then you can say, okay, there's two choices for how to read this formula. I could say, is this true? Is x greater or equal to 0? No. So I ignore that because this negative 5 is less than 0. So that means if I'm using this formula, we're going to go to the second part, the negative x. We're ignoring the first part there, and because x is not greater than 0, so we're going to get negative 5, which then is just equal to positive 5. So that's how to read that. You either apply the first formula if you have a positive number. So for example, the absolute value of 6 is just equal to 6. But if you plug in a negative number, the second one tells you how to change the sign to make it positive, to represent a distance. So these two definitions give you the same thing. Let's do a couple examples of trying to use that. I'll do this one first, real quick. So for A, when you're doing the absolute value of 3 minus 8, we have to do that first. That's going to become the absolute value of negative 5, because 3 minus 8 is negative 5. And then the absolute value of negative 5 is, you can think of it two ways, either the distance from 0 to negative 5, which is 5, or you could also think of it as negative 5 using the second definition, which also gives you 5. Either way, the answer is 5. For part B here, the absolute value of 3, this whole thing here, that's just going to be the distance from 3 to 0 on a number line, which is 3. And then the absolute value of 8 is just 8, so you get 3 minus 8. And then after you do that absolute value, you can subtract them and you get negative 5. So we see that these are not actually the same thing, even though they kind of look like it. All right, now let's go to exercise 2. This is one I want you to do. So let's take a moment to pause it here. Here's my answers. And the most common mistake with problems like this is to get mixed up with the order of operations. Remember, you have multiplication here you have to do before you can do the 12 minus 3. So multiply before you add. Same thing here. You need to do the whole absolute value so that you can multiply 3 times that, 7, because you need to multiply before you can subtract with the order of operations. So that all comes out to negative 28. So here's a quick reading question for you to do. This is just true or false. And when you have a thing like this with variables, it should be true for all values of a and b if you think it's true. If you can find one value of a and b that makes it not work, then that makes the whole thing false. So try some different values of a and b and see if you can break this equation. See if you can make it false. Here's an example of a value of a and a value of b that makes this equation false. If they're opposite sign, anything where they're opposite sign should work just fine. So for example, 3 and negative 4, the absolute value of 3 plus negative 4, that's like the left side of this, comes out to be the absolute value of negative 1, which then becomes 1. But if you do the absolute value of 3 and negative 4 separately, you'll get 3 plus 4, which is 7, and 1 is not equal to 7. So that makes it false.